Hi guys, good evening, good morning. This is gonna be a new YouTube section about how to design a pneumatic system. We are gonna see these 6 topics about compressor selection and sizing. That is the topic of today. And then the next week, next week, we are gonna see the air receiver sizing and selection. We in that part we are gonna do a calculation of how to do it. This to select this air receiver. I don't know. Then we are gonna selection the correct dryer. Then about the pipe size calculation. Then the air filters and water oil blower. This is a plus of my sections. And then remember that the air compressor or pneumatic system it's really expensive. So we are gonna see a section about the energy consumption or energy efficiency calculation. So let's start. I imagine I make this situation about a pneumatic system. It could be in a tool shop or a factory, whatever. So I put these pneumatic tools. This is a case of a reverter, drill, nut runner. This is start. So imagine that you wanna assemble a product and you need these tools or for something in a paint shop might could be you have a pneumatic tools. So uh, you so I put this 3, could be more, could be others. So that depends of you. I put this, but this is gonna help us to start off this selection of until the energy consumption topic. So the first question that you should do is how many tools that I will have. So in this case we have a reverter that is a reverter, 4 drills, 2 nut runner. So I put this is something that I imagine you could put more or less. That's depend of you. And then you are gonna search in the data sheet the flow of these tools. In this case is 2.2. This is a real information. 7.5 and 21. So in this case for drills over the 6.5 millimeters and above 10 millimeters, and not runners for over 10 millimeters. So then you have a consumption, because this is 2.2 just for one, you have 8, so the total is just multiply. So it's the same for these 3. Then you should consider, and it's mandatory, you shall consider the use factor. What does it mean? Does it mean that something that imagine that you have, this is something that I do. Imagine that you have your working schedule for the day, it's 8 hours. So in 8 hours you have a break, you go to the bathroom, maybe you have more breaks, I don't know, or something, your ergonomic exercise that you do. So it could be your security conversation that always should be. So there's a time that you are not using that tool, the pneumatic tool. So I put the 7.8. What does it mean? That if of all the time that you should do these pneumatic tools or the reverter, you are using in the real, that's 94% of the time. You can also consider it 100. It's possible or less. That's gonna depend of you, depend of the working situation that you have. Okay, the use factor is not similar of a simultaneously factor, but we are gonna use that meaning because it's maybe so difficult to think about. Okay, I reverted, and then 3 second then I'm gonna drill, So it's some difficult. So in this case, for as in the case of we think simultaneously, we are gonna think that 100% or just one, the total. In the case of use factor, that's gonna depend on you. So you can also consider 100. So don't worry. So then now you have a total demand, but the time it's gonna depend of the time. So you have a total flow now, a new total flow now. That is okay. You should multiply the percentage of use factor of in the case of the consumption per quantity. So you have a total flow for converter, for drill, and not runner, and then you're gonna uh, sum of that, and then you see this is a total flow. In this case, is 84. This is in Spanish because I'm a Spanish speaker, so be patient with me if I make some mistakes in English language. I'm in Spanish, so I'm sorry if I uh, maybe slow in some words. Then you should know your working pressure of your system. In this case, it's something typically a 6 bar, maybe could be 5, 7. This is something that you will see in every place, in every floor. And then the dew point. This information is also in the data sheet of the tools. So I put something that it's normal, could be less. It's okay. That's gonna depend of for what you have your pneumatic system. So in this case, we put 6 degrees. If you see, it's in Celsius because here in Latin America we work in Celsius. I know that in America working in Fahrenheit or maybe in other. So I'm sorry. It's in this case Celsius is normal for me. I'm sorry. So then so this is the start situation, and this is the important. This is the for the base of all the selection that we gonna have. Then I put this. This is not gonna help us in this part. This is gonna help us for the dryer selection, air filters in this case. So, but it's a start situation. It's the beginning, so we should mention. So we have the minimum room temperature is 15. This is a case of a place near to the sea. In this 30 degrees in summer, the maximum room. So we have an average of temperature of 22.5. Then we have a room pressure of 1. And humidity, we have some note for humidity in the case of maximum moisture of 86, minimum 69. So we put an average relative moisture or humidity of 78 percentage. Next, this I want to show you. When we finish of the selection, I'm gonna talk about these pictures and this part. Then we are gonna continue with the compressor sizing. So okay. The okay, we have the total flow, that is the sum of this 84. We start. Now you should consider some over designing. What does it mean? Imagine that today or tomorrow you don't want an 8 reverters, you don't want 4 drills, you want more, 5, 6, 10, whatever. That's gonna decide by you. So you should consider in this case an over design. Some typical I'm sorry. That's like a spoiler. Some typically percentage it's 10 or 20%, but it could be more. That's gonna depend of you. So in this case, I decide depend of you or the situation for what you want this pneumatic system or the factory. Imagine that you are assembling, and in the future now I don't want one assembly line, I want two or three. So that's something that you should know to not buy a compressor again. So imagine that. So in this case, I consider the 20% of over designing of the total flow. You see, is the 20% of the total flow, and this is gonna make in every war in every factory air leakage. In every factory that you would go, or every place, there's always air leakage. Typically, a good air leakage controller or manage is 10%. Could be less, but could be more. So how can I know how many leakage consideration that I have? That's gonna depend of the for the place that you are designing this pneumatic. Uh, in this case, I consider 20%. But imagine that you are designing a good air system, pneumatic system, but the maintenance area doesn't have a plan of to do the preventive, predictive, I don't know, maintenance of that pneumatic system. So when there's gonna be a leakage, this leakage is gonna increasing by the time. So could be more percentage. So that's the reason why I put 20. But I think in a normal condition, 20 should be the maximum that you should that you allow for your air compressor demand. Because if it's more, uh, you're gonna losing money. You are wasting energy. So I put 20 in this case, but it should be 10. So then you are gonna plus off of that, and you should have a new total demand. So then you plus these three, and then you have 180 liters per second. Or you can convert this case cubic meter per minute, or in the case cubic feet per minute, well, 249 or 250. So now I'm sorry, now you know the correct demand of the air compressor. So now you are in a good place to select your compressor. So in this case, we select this Schuler of the 45 class. In this case, 400, 500, 4000, sorry, 509. And as you can see, we need 7.1, but you should select what is in the market. So in the market, I have in this case 7.5, so I should select. I don't select this because it's 7.7, so I need more, and this is too much for this. So if I consider more demand and the total it's maybe 8, so I go this. But in this case, no, it's a different situation. We need 7.1, so this is 7.5. It's okay, we should select it. So that's how we and you are gonna select the compressor, air compressor. In this case, it is a stationary compressor, but you should consider this. Well, until here. Why? Because this is the structure of your pneumatic system. The demand, what is gonna depends. What depends of the flow of this, the demand of these tools, and the time. So in this case, for this situation, we have a correct compressor selection. I'm gonna talk something here that is gonna help you for the next weeks. So this is a picture of a typically situation of in factories. This is a picture of Kaji. Kaji is like the institute of air compressor air system. So it's like the queen of the rules. So this is the discharging uh, pressure, the charging pressure. Then we have some drops of the all sizing piping that we have, more drops for the distribution system, and then for some maintenance unit like F filters, regulators, valves, housing, so could be more. And then I put these some pressure drops in bar that we are gonna use for our design. These values are something for here, and then other values I for Atlas Copco that I find that it's typically values we are gonna see the next weeks, but I put here to remember and to have it like an extra information. So these drops we are gonna use for our design. These some typical values. If obviously if it's less, we have less drops, it's better for us. Well, just omit this picture. This is something that I put to just to say it. We are gonna not gonna use it. This is some situation for different industries. So okay, guys, this is all. That's all. That's all. Uh, how to select your air compressor. So now we know we finished the first step, that is the compressor selection or sizing. And consider all that you should consider. The next week we are gonna calculate the air receiver sizing. So to have a good consumption of the air, depending by your demand, air demand. So okay, guys, thank you for your time. I hope that you understand it. If you have any question, do not hesitate to do it. Just please put your comments or your question uh, to help us in different videos, and this is gonna help for all people that could be have the same question. So just do it. Thanks for your time and have a nice day.